I'm John Strum, and this is Real Talk MS. It's October 24th, and we have a lot to talk about. There's still a lot of research that was presented just a couple of weeks ago at the Joint ECTRIMS-ACTRIMS Meeting in Milan, and we're going to get to some of it in just a moment. I had the good fortune of speaking with lots of presenters at the Joint ECTRIMS-ACTRIMS Meeting, so I'm inviting you to catch the series of ECTRIMS Extra conversations that I'll be releasing all week long. It's an opportunity for you to listen in to my conversations with some of the top MS research and clinical experts in the world. Speaking of which, I had a conversation with just such an expert when I ran into Dr. Helen Tremlett at the meeting, and we had a chance to talk about the importance of her pioneering work in understanding the prodromal phase of MS. But before we get to my conversation with Dr. Tremlett, there are a few other things that you should know about. When myelin is damaged in the central nervous system, our brains have the ability to regenerate fresh myelin. Even in the early stages of MS, the body is still able to remyelinate after a relapse. But for people living with MS, that repair system falters and eventually stops functioning. Now imagine if it didn't, because that's what Dr. Jeffrey Huang at Georgetown University is thinking. Currently available MS therapies target the immune cells in the blood, but not those in the brain. Now, resident immune cells in the brain are called microglia, and their job is to clear damaged cells out of the way so that fresh cells can take their place. But in later stage MS, microglia becomes inflamed and aggressive and continue to cause damage to myelin in the central nervous system. Dr. Huang is testing a drug that arrests this process in microglia and returns them back to their original function of clearing damaged cells and helping to keep things running smoothly in the brain. His team has already used this drug treatment to successfully treat mice with the mouse version of MS, successfully causing remyelination by stimulating the microglia, which then starts a healthy chain reaction throughout the brain and spinal cord. The next step is human clinical trials for this novel treatment approach that could stop MS progression and stimulate remyelination. For people with later stage MS, this could be a true game changer, and we'll keep you updated as work on this therapy continues. You'd think that all the news about how COVID-19 might affect people with MS has already been shared, but a recently published report by Deloitte Access Economics serves as a serious reminder that the COVID-19 pandemic has impacted us in ways that many of us haven't yet considered. The Deloitte report is titled The Socioeconomic Cost of and Impact of COVID-19 on Multiple Sclerosis in Canada, and it quantifies the financial impact of changes in treatment and delayed diagnoses for people living with MS in Canada. That financial impact is estimated to exceed $500 million in extra healthcare costs, lost productivity, and worsened well-being. The term pandemic gap refers to the time during the COVID-19 pandemic when patients weren't receiving their normal treatment or even being seen or diagnosed in a timely manner. The Deloitte team first estimated the total cost of MS healthcare in Canada in 2019, the year before the pandemic. That number was estimated to be $3.4 billion, which breaks down to about $42,880 for each person living with MS in Canada. In the years 2020 through 2022, that's the pandemic gap, Canadian MS-related healthcare spending declined by about $566 million. Using economic models, the Deloitte researchers have estimated that the pandemic-related disruptions in healthcare delivery will lead to just over $578 million in additional MS-related costs between 2020 and 2024. In concluding their report, the Deloitte team reminded us that even experts don't fully understand all the ways that the COVID-19 pandemic will impact people living with MS, writing that their estimates will require updating as the longer-term outcomes from the pandemic are realized. Evidence shows that early intervention in treating MS makes a difference in slowing disease progression. So when we talk about people not being diagnosed or having to skip their infusion therapy, that equates to people risking greater disability in the future. MS Canada has requested that the Canadian government offset this misstep in healthcare delivery by investing $15 million in prevention and treatment research focused on more fully understanding the link between the Epstein-Barr virus and MS, and increasing the availability of MS specialists by funding additional MS healthcare professionals. Canada has one of the highest rates of MS in the world, with an average of 12 Canadians being diagnosed with MS every day. And while this may be one of the first studies to focus on the economic impact of the so-called pandemic gap in healthcare, it's not likely going to be the last. We haven't seen an analysis like this applied to MS healthcare in the United States, but it doesn't take a math whiz to realize that there are about 90,000 people living with MS in Canada and about 1 million people living with MS in the United States. So it's safe to say that the same sort of disruption in healthcare delivery during the pandemic in the U.S. may have created an economic outcome that's many times more costly than the $500 million that's already been identified in Canada. If you'd like to review the report from Deloitte Access Economics, you'll find a link in today's show notes. An oral presentation at the recent Joint ECTRIMS-ACTRIMS meeting by Dr. Pietro Iafaldano, an associate professor of neurology at the University of Bari in Italy, provided evidence that people with relapsing remitting MS who had an early start on so-called high-efficacy disease-modifying therapies experienced slower disease progression compared to people with relapsing remitting MS who were treated using the escalation treatment model. High-efficacy disease-modifying therapies are believed to be better at slowing disease progression. Yet many neurologists use an escalation approach where they first prescribe a lower efficacy DMT that carries fewer potential side effects, and they only switch their patient to a higher efficacy DMT when that patient shows signs of disease activity, like a relapse, new brain lesions, or disability progression. Using data from the Italian MS registry, the researchers analyzed people diagnosed with relapsing remitting MS who were prescribed their first disease-modifying therapy within 3 years of their diagnosis and then were followed for at least 5 years. They found 908 people who were initially prescribed a high-efficacy DMT, and they were able to match their clinical and demographic characteristics with 908 people who were initially prescribed a lower efficacy DMT. Now, in this study, high-efficacy DMTs include Gilenya, Tysabri, Novantrone, Lemtrada, Ocrevus, rituximab, and Mavenclad. Patients in the escalation group received Copaxone or its generics, interferon therapies, Aubagio, or Tecfidera or its generics. Disability for all study participants was measured using EDSS, or the Expanded Disability Status Scale, and all the study participants were assessed every 6 months for up to 10 years. As a reminder, EDSS is the method that neurologists use to quantify disability in MS. EDSS uses a scoring system of between 0 and 10 to characterize the level of disability in someone living with MS. It's used in assessing people with MS, it's used to monitor changes in disability over time, and it's widely used in clinical trials. The results of the study showed that the mean annual increase in EDSS scores was significantly higher in the escalation therapy group compared with the high-efficacy group, indicating that the study participants who were started on lower-efficacy disease-modifying therapies experienced faster disability accumulation. The results of this study underscore the importance of neurologists having a clear understanding of each patient's goals and risk tolerance, and each patient having a clear understanding of why their neurologist is recommending a particular disease-modifying therapy. It's the very foundation of shared decision-making. You can expect to hear much more on this subject from larger studies that are currently underway. Speaking of high-efficacy disease-modifying therapies, another poster presentation at the combined ECTRIMS-ACTRIMS meeting showed that a new under-the-skin formulation of Ocrevus, administered in just 10 minutes, is at least as effective as the approved intravenous formulation for people living with MS. Most people who were given the subcutaneous injection or the IV formulation of Ocrevus in this trial experienced a drastic reduction in B cells within a couple of weeks, and the majority had no relapses or new MRI activity over 6 months from the date of their treatment. This new formulation of Ocrevus is designed to be administered by a healthcare professional by injection into the tissue layer between the skin and the muscle every 6 months. And the advantage, of course, is time and access. The proposed subcutaneous injection takes 10 minutes instead of spending a couple of hours receiving an infusion. And perhaps most importantly, you don't need to get yourself to an infusion center, which for many people can be difficult. Now that safety and efficacy have been shown, Roche, the manufacturer of Ocrevus, is running a phase 3 clinical trial testing the pharmacological properties of the proposed subcutaneous formulation compared with the intravenous formulation. Specifically, the research team is studying the amount of Ocrevus that's active in the body 12 weeks following treatment. If you'd like to review the details of this poster presentation, you'll find a link in today's show notes. If your MS is being effectively managed by your disease-modifying therapy, at some point, it may cross your mind that your MS is stable enough that you may not need that DMT. It seems like a fair question to consider. And when or if you find yourself considering that question, I hope you'll consider what researchers in Amsterdam recently learned. In a presentation at the recent Joint ECTRIMS-ACTRIMS meeting, Dr. Eline Korver from the MS Center Amsterdam in the Netherlands presented data from a clinical trial that was designed to determine whether disease-modifying therapy could be safely discontinued in patients with stable disease. Now, the study had already recruited 89 participants who were living with relapsing remitting MS or active secondary progressive MS who hadn't experienced a relapse or shown significant MRI activity in the 5 years leading up to the study. The researchers also limited participation to those people who were receiving lower efficacy, so-called first-line DMTs, including Tecfidera, Copaxone, Aubagio, and interferons. The study participants were randomly assigned to one of two groups. One group continued using their disease-modifying therapy, and the other group stopped using theirs. And the headline here is that the clinical trial was stopped after an interim analysis showed increased disease activity, either a relapse or new lesions on MRI, among people in the group who had stopped their disease-modifying therapy. 2 people in this group experienced a relapse, and 7 had 3 or more new lesions, or 2 existing lesions that were now showing active inflammation on their MRI. None of the people in the group who had continued their DMT experienced any increase in disease activity. So, if your MS is so well managed that it's been years since you've experienced a relapse or had any new lesion activity show up on MRI, please consider that your DMT is working, and please stay on it. If you'd like to review the details of this presentation, You'll find a link in today's show notes. At the top of this podcast, we talked about a novel therapy that may deliver real benefits for people with later stage MS. But what if we could identify MS before anyone actually experienced any of the typical clinical symptoms? Would treating that person with a high-efficacy DMT prevent those clinical symptoms from even developing? Those are the questions that make the study of the MS prodrome so fascinating and important. At the Joint ECTRIMS-ACTRIMS Meeting in Milan, I was able to speak with one of the foremost experts on the prodromal phase of MS, Dr. Helen Tremlett. In a moment, we'll hear that conversation. I'm at ECTRIMS 2023 in Milan, and Dr. Helen Tremlett is at this conference, where she'll be giving a presentation titled, "Can We Reduce the Risk of MS Conversion and Progression?" This relates to what experts like Dr. Tremlett are learning about the prodromal phase of MS. Now, I've had the pleasure of talking with Dr. Tremlett a few times in the past, but this is our first face-to-face meeting, and it's nice to see you.
Oh, it's a real pleasure. Thank you, John. It's lovely to meet you in person.
Just to bring all of our listeners up to speed, I hope you'll explain what the MS prodrome is, and then tell me, what are we learning about the MS prodrome?
Yeah, so the MS prodrome, if you can imagine, are early signs and symptoms occurring before classical onset of MS in an individual who then goes on to be diagnosed with MS. So MS onset, a classical MS onset might be something like issues with vision, optic neuritis. So we are realizing that in the years leading up to that individual developing MS, having these classical MS onset symptoms, that they're more likely to be hospitalized, visit a physician, fill a prescription for any kind of medication or a diverse range of visits to doctors and so on. And we're picking up things like fatigue, irritable bowel syndrome, pain, and they all seem to be elevated in those individuals in the years leading up to MS onset relative to people who didn't go on to develop MS.
So when we talk about the risk of conversion, you're really talking about that moment or that time when we have that traditional MS onset. Is that right?
You know, I'm being given that title. That wasn't my title. And I wouldn't use the word conversion, because to me, if someone's in the prodromal phase of MS, they already have MS. So the conversion bit is the wrong word. I would just say at some point they have a classical sign such as optic neuritis, which we've always understood as being MS onset, and then they will fill diagnostic criteria for MS. So in the prodromal phase, they already have MS. The disease has already biologically started. But at the same time, I do think there are implications potentially there for understanding how to prevent MS. And I'll give you a key example, right? So if this prodromal phase lasts 5-10 years before MS onset, if you want to know what causes MS, then you need to look back further in time than 5 or 10 years before MS onset. Otherwise, you may be inadvertently picking up something that's actually part of the prodrome. That person probably already has MS, and you think that may cause MS, and that could be an erroneous conclusion. So that's what we can do right now with this information that we're uncovering in context of the MS prodrome.
So maybe if we look a little ways into the future, and I'm hoping it's only a little ways, can you connect the dots between the concept of understanding what characterizes the prodromal phase of MS and then leveraging that understanding to prodrome some sort of clinical intervention?
Oh, that's a great question. I mean, many answers to that question. I suppose, first of all, I'd say we're not there yet in terms of being able to reliably identify people in the prodromal phase. Historically, this prodromal phase wasn't thought to exist. So our first step was to show it existed. And now we're really trying to unpack what is part of that prodrome and what is specific to MS versus might be common across other autoimmune or immune-mediated diseases. So we can't use this information yet clinically, but I do think there's potential in the future that we may be able to identify people in this prodromal phase of MS with a certain level of reliability, and therefore maybe in the future we could offer those individuals enrollment in a clinical trial, for example, of a new novel therapeutic or a medication that may perhaps delay onset of MS and may prevent future disability progression. That would be a long-term goal.
And that would be amazing. It would not technically, I guess, be a cure, but I think for that individual, it would feel like one.
One would hope so. That's right. One would hope so.
Well, Dr. Tremlett, thank you for focusing your research on an area that can directly lead to stopping MS literally before it starts. And as always, thanks for talking with me today.
Oh, it's a real pleasure. It's so lovely to meet you, John, and thanks for your interest in this work.
That's going to wrap up this episode of Real Talk MS. Real Talk MS is powered by the National MS Society. And you can share this episode of the podcast by letting your friends or family members know that all they have to do is point their web browser at realtalkms.com/321. You'll find that link in today's show notes, so you can easily copy and paste it right into an email or a text. And if you have a minute, I hope you'll visit the Apple App Store or the Google Play Store and download the free Real Talk MS app for your iOS or Android smartphone or tablet. It's the best way for us to stay connected. The app will automatically download the latest episode of Real Talk MS. You'll be able to access any of our past episodes. You'll be able to save your favorite episodes. And it's a great way for me to share bonus content with you. The app is free, so I hope you'll download it today. I'm John Strom. Thanks for listening. Stay safe and make healthy choices.